Hello friends, Namaste and welcome to Ramesh Knowledge Index. I am Karthik Jha here, back with another interesting video, and today we will be discussing about this interesting expression, that is a square plus b square. If you remember, in one of my previous videos, which was titled a power n plus or minus b power n, I discussed about a special case, that is a power n plus b power n. Okay, wherein I told you that if n is odd, then you can be very sure that a power n plus b power n is divisible by a plus b. And a good example to this is a cube plus b cube. And a plus b itself is a very good example, because one is odd. Okay, so if you want to see that video, just check out the description. Now today, but I did not talk of n being an even number. Okay, so today we will be discussing a special case wherein n is 2, which is an even number, if I'm not wrong, and these two numbers differ by 2. And this has been a recent breakthrough in mathematics. It has been discovered by not 30 or 40-year-old mathematician. It has been discovered by 9th standard or 9th graders from DPS. So I think you must give this. I will pose a problem in front of you. You give that problem a try solving it, because if 9th standard students can, then of course you can also try it. And then we will look into the theorem that they have proposed, and also its corollary. So the question that you need to solve is this, to get to the theorem. What is the remainder when the square of two positive integers which differ by 2 are divided by their sum? So of course you need to assume some two positive integers and then divide the square of these two positive integers with their sum, and whatever remainder you get, you need to find that. Okay, so pause the video and give this problem a try. Moving towards the solution. Now, first and very basic step is to assume that the two numbers are n and n plus 2. Then we need to find the summation of the square of these numbers. Now, if you find n square and n plus 2 whole square, you get something like 2n square plus 4n plus 4, because n plus 2 whole square can be expanded by a plus b whole square formula. Okay, now you will get this. The first intuition that comes after seeing this is to take 2 common out. Correct? So I took 2 common out. I got n square plus 2n plus 1. Seeing n square plus 2n, I think I can go somewhere to n plus 1 whole square, isn't it? But for that I need 1. So I can write 2 as 1 plus 1. Okay. Now this term, I think this whole can be represented as n plus 1 whole square, and then leave this aside for a moment. So you would get 2 times of n plus 1 whole square plus 1. Okay. N plus 1 can be written as n plus 1 into n plus 1, and that's quite obvious. 2 times of n plus 1 into n plus 1 plus 2. Now what do? I multiply 2 with this n and also this 1. I think this is called distributive property. So then what you get is 2n plus 2 whole into n plus 1 plus 2. Okay. Now why did I multiply 2 with n plus 1 and n and n plus 1? I mean, why did I multiply 2 with n plus 1, only one of the n plus 1? Now there is a special reason for this, and if you look, we are trying to divide the number or the square of these two natural numbers by their sum, and if you try to find out their sum, that turns out to be 2n plus 2. Okay, for those of you who are in class 10th, it will seem to be like Euclid's division lemma, okay, wherein you have the dividend here, the divisor here, the quotient is this, thus the remainder will be 2. Correct? So you tried to represent the dividend in terms of the divisor. Okay, that's why I multiplied 2 with n plus 1. Okay, for those of you who don't know what Euclid's division lemma is, no worries. If now you understand that this is the divisor, getting my point, this is the divisor and this is the dividend, correct? Dividend can also be written in this form, like let me erase all ink. Okay, so this is the divisor, I represent it with small d, and this is the dividend. This is also the dividend, okay, which basically means that you need to divide this number with this, correct? So when you will do that, you can separately divide this by this and then this by this, correct? When you divide this particular number by the divisor, the remainder that you will get is 0. Why? Because 2n plus 2 clearly divides 2n plus 2. So the quotient left would be n plus 1. So that's very clear. So this would cancel this and then you would be left out with n plus 1. Now you divided it with this, now you need to divide with this. Okay, so 2n plus 2. Now will 2n plus 2 divide 2? Good question to ask. Like let's say we have assumed that n is a natural number, the smallest possible value of n is 1. Okay, and if n has the smallest value, then 2n plus 2 will also have the smallest value as 4. Okay, now all the divisors of 2 will be smaller than 2, and there are only two divisors, 1 and 2 itself. So 4 is not a divisor, so 4 will not divide 2, and any number greater than 2 will never divide 2. So basically we can conclude that when we try to divide 2 by 2n plus 2, we will be left out with remainder, and that remainder would be 2. Getting my point? Because always you will have a number greater than 2, so when you divide it by when you divide 2 by a number greater than 2, then the remainder will be 2. So the remainder left out would be 2. I think if you did not understand, I can once again explain you. We are dividing this number by this number, okay? So as we have a plus sign here, we can divide this number by this first and then by this, okay? And then because you know the addition of two fractions with same denominator will yield you the same result, okay? So if you divide 2n plus 2 whole into n plus 1 by 2n plus 2, the remainder will be 0, but when you divide it by 2, the remainder will be 2. So the overall remainder that would be left out would be 2. Okay, so I think that's very clear. Now what was the theorem that was stated? Nothing, just the formal representation of what we have studied. They said that when the square of natural numbers that differ by 2 is divided by its sum, then the remainder obtained is 2. And that's how simple it was. So if you have two numbers, let's say a and b, and you find a square plus b square, then they can be represented in the form of a plus b into q plus 2, which means the remainder will be 2 if b and a differ by 2, which means either a minus b is 2 or b minus a is 2. Okay, any way around. That's why I put this modulus sign here. Okay, now there is a corollary to this particular theorem, and I want you to try to find out what the corollary is. I'll give you a hint. See, if you are able to represent the quotient that is obtained in the terms of the two numbers, then you can formally articulate the corollary. So if I'm not wrong, the two numbers are n and n plus 2, okay, and the quotient obtained is n plus 1. Okay, so now how will you get this from this? Okay, and that's the question, and if you are able to do that, you are successful in finding out the corollary. Okay, that's it for today. Hope you enjoyed the video. Have a sweet Sunday ahead, and thanks for watching. If you liked the video, please like, share and subscribe my channel. Press the bell icon to stay updated, and also don't forget to leave your comments, because your suggestions are always welcome. Thank you once again.